All right, awesome. And we had a little bit of a, I guess, late Twitter notification because of a technical snafu, but we're here at the same time basically every week. So you can always show up here for some kind of Scala or ZIO related content. But today so next week we've got the ZIO hackathon coming up, which I guess last couple of years been once. Last one was about a year ago. Probably do a little more frequently as we hopefully get past the pandemic. But really exciting opportunity for us to come together and all work on different fun things that we're excited about. And this is going to be the first one where we're at least a little bit in person. At least a small subset of us are going to be getting together in Colorado in the US. And I think there's a contingent that's trying to get together in London. But if you can't, or you're in any other part of the world, you can join remotely. So it's open to everyone. And we're going to get started on Friday next week. We're going to have a set of just talks of kind of introduce people to ZIO. If you knew the introduction, we'll have a little intro to some of the different projects. We got a whole bunch of projects. We got like ZIO HTTP. We got ZIO CLI, ZIO Flow. There's a ZIO U-ring one for folks who want to get into some very cool, like low-level stuff, kind of intersection of Scala and Rust. We got some stuff on ZIO Core and adding some new concurrent data structures. So we got like lots of fun stuff for people to get involved with. But we thought today we would kind of kick that off and just kind of go through the just doing a pull request on something. We've done a couple of other sessions like this. We did one with John where we did a contribution to ZIO schema, but I think we actually ended up not getting in fast enough, and then Dan just did, which is fair. And we did another one with Ash where we had a little bit of an introduction to ZIO Flow. So yeah, I just kind of take the mystery out of like doing open source stuff, because I think like once you do it for a while, it's like no big deal. But like if you haven't done it before, there's just a little bit of a barrier of like, how do I clone the repository? Like, how do I like take an issue? Like, how do I communicate with people? And so we just kind of want to like hopefully like take any like concerns of that away, so that like everyone can be super comfortable contributing. And there's also gonna be a whole set of issues of like different levels. So if you want to do something easy, there'll be easy things. If you want to do something like hard, they'll like take a bunch of days. You do that. There's lots of stuff in between. And so today we're going to do a pull request for ZIO CLI, which is actually the library that Kit is going to be the team lead for on the hackathon. So each of these projects, there'll be like a dedicated lead who is going to like explain the project a little bit. It'll be available during the hackathon, at least at whatever their normal hours are, because we're going to be a global event to answer questions or help you out, or even potentially live code with you. And so with that, maybe I'll turn it over a little bit to Kit to give us an introduction to ZIO CLI.
Yeah, let's see what happens. It's been a little while since I've used it, but or slash poked around with it. But yeah, the purpose of this hackathon is going to be to get it nice and shiny and over the finish line for real, even though much of the work has been done, but it needs some polish and some extra features. So basically, what it allows you to do is create command line interfaces, hence the CLI part. Here is an example. There are a couple of examples that we could take a look at in the examples directory. There's one for Git, just a very minimal subset of Git here, where there is a, what do they have? 2 subcommands. So you can have subcommands, and these each of these subcommands can have sort of their own options. But it's kind of nice in that this seal trait subcommand thing is just your own creation, right? So you basically create a data model, an ADT, that represents sort of your CLIs, the different commands you can run in your CLI with their options sort of as parameters. So if we thought about Git as a data model, we might represent it as a seal trait that's a subcommand, where you can either call git add or git remote. And obviously there are way more settings, right? So we might add like git clone or something with the URL being a string as well if we wanted to. And then you have sort of the options for each of those commands as their parameters, right? So when you add, you can select whether or not to include only the modified ones. I think that's like -m is that setting. And then a directory, which is basically what directory would you like to, what path would you like to add to your Git? And then remotes is just the remote command that would list all your current remotes. So if I run these in my actual Git, we'll see that git remotes, we can run this and it shows the list of remotes. And if you say git remote -v or git remote -- verbose, it will list them along with their actual URLs. And so this is sort of a data model that can represent these commands. And so all that Git ZIO CLI does is basically create a parser for these commands based on the command line input and sort of give you all of the out-of-the-box things that you would want. Obviously, you have to write your program yourself. You basically write the type you'd like it to generate for you. You describe how these should be parsed, and then you have to actually write your implementation. But what it can do, so here, let's take a look. So for each of these subcommands, we basically have our own, this is where you actually start using ZIO CLI. You describe this command type. So it's nice and composable. Even though it's a subcommand, we still consider it a command, and these would just nest in some ways. So we have a command called add, and that obviously would have this parse the word add after our application command. And then it takes two arguments. So command takes first the name of the command, then its options, and then its arguments. And then maybe a help doc message if you want. So the difference between options and arguments is something like anything that you use dashes generally in sort of whatever conventions there are for CLIs. You basically have a series of flags potentially, so Boolean flags, and then also potentially some sort of options where you might give it a value. And then you have maybe a set of arguments, usually like path names or something, right? So for git add, the arguments would be the directory. And so that kind of handles both cases. And these are two separate arguments to handle the slightly different semantics that they have. Options being generally, you have let's go through it. For git remote, you have the short version, right? So verbose is a Boolean flag, so you both have the short version and the long version. That's a common thing for options. Whereas if remote did take arguments, you would just have like a path name or something in here. Git ignore something. Obviously, that's not how git remote works. And you can kind of see, yeah, okay, so there are more options here, everything that starts with that dash there. And then here at the end, inside of these angle brackets are the arguments. So that's the differentiation between options and args. And so for add, we have a modified flag, which is that -m that you can use or not use. And then the arguments is a directory. And each of these types, options and args, have some helpers for you. So you can parse out a Boolean. So options.boolean, options.string, or I think text currently. I'll probably change that to string. And other things like local date time. So much stuff. I think directories here as well. And there could be validations that you've input the right types here. We'll take a look at that in just a moment. And this will make sure that this directory you give it as an argument actually exists. So you have an option to enforce the existence of a directory. And then you take basically the types yielded to you by each of these parsers, sort of the options parser and the args parser. You get a tuple back for each of them, containing each one on each side. So we have a Boolean over here, a path on the other, and then we translate this into our subcommand. So we get back a command of subcommand add. So this is basically going to parse out an add for us based on the name there and the correct flags. And then we do the same thing with remote down here. So we have its own Boolean flag, its own directory flag in this case, and it doesn't have any arguments. And so now we create our remote based on whether or not it should be verbose. Actually, I don't think we're using the config path in this example, but we theoretically could. Okay, and then we sort of create the root command, which is what we're going to actually call, right? Which is git here, and we're giving that a command git, we're not giving it any options or arguments because this command exists only to have subcommands. And we can join these and sort of alternatives with this little pipe operator. So you're going to type get add or get remote. And then it is calling, and the way this seems to work, subcommands is it returns you a tuple of the result of that subcommand as well as any other arguments. So if get has its own options and args, those would be in the first part of the tuple. But we don't have any in this case, so we just map those away, returning just the subcommand there that we got. So this gets us a command of a subcommand. Okay. And then lastly, at the top of this, we make a new CLI app, giving it a name, a version, some summary text, and finally the command. And then we have the option to, let's take a look at the signature here. So our command parses out some model. Really, this is that seal trait that we made for subcommand. And then we pass as a secondary parameter list a handler that takes the model and interprets it into ZIO. So this is where the actual ZIO part comes in at the end, where you can take the sort of the data type that you have described how it should parse using these command options and args primitives that you've composed together, and then you interpret that thing at the end in whatever way you want. So we're matching on our seal traits, and really just in this case printing out what we have done. Cool. And you get some other things for free. So right now, if I run this down here, and I just do get example help, we'll see that it can introspect itself on the commands that we have. So it says, okay, you have these two subcommands, add and remote, and then you have some options, and it sort of knows a bit about the structure that you should write. It even says git up here. I don't even know where this is coming from, to be honest. Oh, I think probably there. I don't know. Something clever is in here somewhere. So that's nice. Someone has some nice ASCII art skills. And so you write git, you write a command, which is described down here, add a remote, and then some potential arguments. And you get help out of the box, and apparently one called shell type out of the box. We could explore what this is because, I've sort of semi-inherited this library. I'm not a super master of it, but we'll figure it out together. It'll be a fun exercise. Nothing up our sleeves. We're going to struggle in front of you. So yeah, that's kind of the idea of the application. So I can run something like, I guess, remote dash. Do I have options here? Or is it just verbose? Oh yeah, so okay, so yeah, that's the idea of aliases. So I should be able to write either remote verbose, executing, oh yeah. and the result is very meta, where it just tells us that it executed get remote with verbose flag set to true, right? Because that's the interpretation here. Executing get remote with verbose flag set to true. So if I remove the verbose flag, it'll just say executing remote with verbose flag set to false. That's kind of how it works currently. Obviously,
and hopefully the real version would do something other than print something to the console when you do those.
Yeah, it would actually do something. But we want to improve it in some minor way, or at least begin to improve it in some way to sort of, as Adam mentioned, sort of show what we're going to be doing for ZIO Hackathon, which is going to be involving sort of like looking at code and getting walked through libraries and understanding how they work. If you're curious about how to build some sort of these like combinator libraries and build these languages of parsers, it's all very nice and neat, these type-safe libraries. And we're going to actually do something because there are.
Yeah, I was just say, do we have an issue for this?
We do. So yeah, so ZIO CLI has some issues, potentially even left over from last hackathon. So I think a few were completed, but some are outlying. And we wanted to take a look at one from the previous hackathon, which is this one. Should be fun, I think, which is auto generation bash script to perform completions for a given CLI. So when maybe everyone's aware of what completions are, right? But if you have some command like git, you can hit tab, and generally you can sort of tab through and see all these fancy commands you have. And you can even sort of like start to type something and then, type A and get autocomplete there based on what's remaining. And it can be relatively intelligent at times. It can also start to like render strangely, I guess. It's, the terminal is always hacky. So the way this works is kind of convoluted, and it actually depends on which terminal you're using. Bash has one way. I happen to use Z shell.
No affiliation with ZIO.
No relation, but it's why, no, it's not why I use it, but it's good. Just a coincidence, I guess. So every bash has its own way of sort of describing how these completions work. Generally, though, you sort of register some kind of handler, potentially a function, a bash function or a bash script, and you tell your own terminal about that, maybe putting inside of some special folder somewhere, and you register that script, and it gets registered with the particular executable, such that when you type the name of that executable up front and then hit tab, it will know, oh, this is the executable that you registered with this script. And so it'll call that script with like whatever argument list you've passed in. And then that script, its job is to return an array of options, which will then get cycled through. And apparently, you can have comments as well, right? Because when I tap, I don't know why it's getting so strange for me here, but when I'm tabbed to AM, it does not actually also autocomplete this comment. That's just sort of an associated help text for this command. So kind of weird, kind of strange, a little hacky. And so we want to be able to support all of these systems. I think there are actually multiple issues, one for each system. Yeah, so there's one for Z shell and one for bash. Maybe there are others. I mean, there are other shells, but perhaps I don't know how many autocomplete frameworks there are. Maybe they just share a couple of implementations. Hopefully that would be nice. It seems already overkill that there are more than one way of doing this. So perhaps we can attack this. I don't really know. We spoke for a couple of minutes before going live here, but I was thinking what we could try to do is to prevent a total sort of just grabbing around in the dark at these various bash script installation techniques. But we have found some tutorials. In fact, John was nice enough to link to some tutorials and docs in each of the tickets for some guidance about how to particularly install these things. What we could do as sort of something that could underlie both features, so maybe leaving that out. If we have time, we'll certainly explore it. But it could be nice to sort of work on the implementation of in ZIO in the ZIO CLI application of autocomplete, given the sort of this command structure that we have, this command seal trait and these options. Given that, and given some partial input string, we're basically going to be writing sort of a semi-pure function that takes our seal trait introspectable description of our CLI application, as well as whatever the user typed after the command name and after hitting tab, and we can return these lists of completions, basically, as sort of a list of strings. And what we could do is expose that operation as sort of a secret argument, a secret command for our CLI tool. And that is the command, that secret command, whatever we do, like if it's our own custom version of Git, it would be Git like, __ completions generator, whatever. And then that would be called by the script that we register with the given terminal complete, whatever framework thing. So that can be done in a generic way, just has to take sort of a string as an input and return a string as outputs. And then we can adapt it at the boundaries. And who knows, maybe that adapting will be the more difficult part of the work here. But at least think about and explore the way this app works. Yep.
Yeah, and I think that's an approach that in different ways we've done with a lot of things. I see you've done, because I think a lot of times we've got our ZIO program and we got to interact with some other thing that is not in a pejorative term, but is not as nice as what we're used to working with. And I mean, sometimes it's like for the work you did on the smart assertions or like the automatic layer construction, it's kind of this like crazy like Scala macros world. And in this case, it's this like crazy, maybe in the opposite way, bash world. And I think both of them, like what you've done is you've kind of tried to put as much as you can into the normal Scala world, and then just kind of call in, like do as little as you have to in that like new world, and just call back into the normal Scala world as much as you can.
Yeah, I mean, yeah, it's one of the great things about functional programming, I think the mindset is that you realize there you can make nice, clean boundaries and sort of just map out into some other interpretation at the end of the day. Everything, you know, in computers just takes some kind of inputs and gives back some kind of outputs. It just happens that with Bash, it kind of feels more like a magical spell just because those inputs are so sort of random and non-standard. And it does not map cleanly onto any type. If it were a typed language, it's just all sort of weird flags that are sort of almost, they seem non-deterministic. But yeah, let's do all the hard work out before considering that stuff. So when we have to focus on that, we can just worry about the ugly stuff that we need to, without also worrying about our app logic or whatever. So yeah, so maybe we should sort of start with, let me sort of like find something, a good starting place. Well, one thing to think about is, so we got that help command for free that I was able to run previously. If I run, you know, git example -- help. This comes from, like, we didn't define this as one of our commands. That obviously comes from the CLI app.make. And if we look in the implementation, it's kind of like, you know, the root of the app. CLI app down here. So yeah, there's this thing. There's some built-in options that just come out of the box for free. And one of them is show help. Fancy name. Oh, that's how it got the fancy name. That's a great descriptive variable name. So basically what we want to do is eventually add another built-in option. It's a secret one, maybe. We'll have to see about that. That can be parsed and maybe not rendered in the help list, because we wouldn't want normal users to call this like complete test completion or generate completions command. That would just be sort of noise and confusing. We can hook it in there eventually. But for now, like, it can be basically a pure function. So I can sort of just, I don't know, make a new object for now and called completions or something. And then we can say def complete or whatever. Let's say generate completions given sort of the input so far, which should be a string. And then sort of I don't really know what to call it, the command, the app. Let's take a look. What does CLI app get instantiated with? Yeah, it's the command, a command of some model. We don't even care about what the parameter is that it returns, because it's useless to us. We're not going to do anything. So really, it's any command we'll do. And we can just ignore the argument there. And the goal, I think, is to eventually generate a list of strings. I'm not entirely sure, but that's kind of my best first guess. Does that look all right to you?
Mm-hmm.
So the idea is, maybe to give like an example, is if we had some app called I don't know, Tamagotchi. I don't know how to spell Tamagotchi. Yamaguchi. I don't think it's Yamaguchi. Pocket Pet, right? Those little pocket things. Say we had a terminal version of a Tamagotchi, and you'd like want to like pet your app, or like, you know, feed it, or dispose waste. It's very important. Otherwise, it dies. That happened to me a lot as a child. So you could pet your pet, feed your pet, dispose waste, right? So if the user typed in, let's just call it Tomo, if the user typed in the terminal Tomo P and then hit tab, we would want basically generate completions to get called. We would expect generate completions to get called with P, and with some basically like sealed trait that represented our command and its subcommands and everything else like that. And really what we care about it here, I mean, at the start of this, things can get complicated, because eventually we can complete with like what option you are at, I guess. Like if dispose maybe has many options, you could say like, and sort of a location, and you could just decide where you want to put it. And maybe that's like a file on your current computer. Maybe you want to start like doing file complete then based on where you are. Or if it's some special other type, I don't know. Maybe it's a Boolean, we could just show true or false afterwards. I'm not sure, but there are other options maybe based on what we know and where they are. But I think the basic starting point would be, if we have a command and there's subcommands, sort of turn these subcommands into strings and then sort of do a very basic starts with filter based on the input and then show the remaining. Does that make sense? And we can kind of take it from there. So
no, so that implies one of the things you mentioned was we're gonna have this list of subcommands. So do we need to have that as a input, or are we gonna know that where this is called?
So that's kind of what command is. So command contains, so let's take a look at the command seal trait. So this is sort of the description
okay, perfect.
of our entire application. And let's see. So what do we have? One sec, sorry. So there are a whole bunch of options for combining it, but the actual cases of this are the following. So there's a single command, which is kind of like what you get when you use the command apply method. So command get or command add, and really takes a name and then options and arguments. So this is kind of the base case. And really, you kind of ignore the actual root command, because that is actually determined by, so the file itself that you're saving it to. For instance, git, you're not parsing the word git here because you're saving your whole executable as a file named git. So this is actually something we should go over. It actually, when it executes, finally, where's the run command? It actually takes it's somewhere here, I forget, is it prefix? No, it's somewhere in one of these things. It kind of unrolls the first command name if there are subcommands, and so it doesn't parse it. So right. I don't exactly know where that is anymore. But yes, that is, we can ignore that one, the root command, because it just is useless. Okay, so there's a single command. Then there is, let's go down, map, which really we could ignore. We don't care about that. That's sort of a concern of execution because it changes the type parameter. We don't worry about the type parameter at all. We just care about these commands, or else. And so or else is kind of how we linked those subcommands together. So we do care about or else, and we kind of want to flatten along the or else to get the names of each subcommand, right? So if it's, what do we have? Pet, feed, and dispose. This might look something like a whole bunch of single pet, or else single, and then another or else single feed, and then single dispose, which would have been written as pet, feed, dispose in this sort of top level of our application.
So do we need a new operator on command here that shows us the subcommands? Because I see right now how we have an ability to add subcommands, but I'm not sure we have an ability to see all the children.
So I think, I don't know, well, we could match on, well, there's also not the guarantee that there are subcommands at all, right? So we kind of just care about like if there aren't subcommands, what are the other arguments?
Can we return like a chunk of subcommands?
Yeah, we could definitely do that. So like put that on, so yeah, get all the commands from our main command and sort of list those out. We can kind of walk through that. And if we find a subcommand that matches perfectly, we can kind of keep walking. Let's see. It would be good to sort of test how autocomplete works in some other examples. So yeah, you're saying on, oh, there actually already is. No, sorry. This is the one that generates the subcommand.
Yeah, it's, I mean, I wonder a little bit, I mean, I guess it's not the most user-facing thing, but yeah, I wonder a little bit if, I mean, you could have like get subcommands or something, but yeah, I almost would have thought that would have returned the list.
I think it's mostly because the API on here is meant to be like user-facing, right? Like this is how they build the thing instead of how to introspect it. But I think we could just have a free function here, like, get subcommands.
Sure. Yeah, we could have it there. We could have on the trait, but and also just for informing us, like I think that says, okay, we don't need the subcommands because we really can get them from the command. So yeah, if we have the command we're in, which could be the root command, and we have the current text input, then we can generate a list of completions. And
this is pretty easy too. I mean, sort of, it depends, right? Because if it's a map, we kind of want to call recursively get subcommands of commands. If it's an or else, well, this is interesting, right? Because it's an or else, we kind of want to just keep nesting the or else and sort of unroll the or else only if it is a subcommands actually. So that's kind of actually a little weird potentially, because we want to flatten. Yeah, because I guess there are multiple ways you could do this, especially with the maps and all. I think we might want some sort of multiple layers of optimization. Maybe we could just first remove all maps because there's really no need to have any maps where we're going. Does that make sense?
Yeah, I definitely agree. We don't need the maps anymore.
And I think there actually already might be something that allows us to, let me go back
Yeah,
to
if there's a
command.
way to get this clear, it'd be good not to have to re-implement this.
Yeah, because I think for help doc, it might already get all of the commands. Oh, well, you know what it does? It probably forces the subcommands operator gets all of its things. So let's see. Parent synopsis, child
I mean,
synopsis.
this is another challenge you run into when you're doing these pull requests. Is a lot of times you can use all the functionality in the library already in the right way. It can be very straightforward, but sometimes there's some thought that has to go into how to do that.
Oh, so there's this names thing, names. So for names for a single operator, it's just itself. For map, it is for its command. For or else, it's the left and the right's names. For subcommands, it's the parent's names, so not the child's names. So that's interesting. So I wonder if maybe that we could just use that already. It'd be good to be able to test this on some, maybe I'll make an example a thing, which is, I think I'll just do my little pet thing. So I'll have the
Yeah, that's a good idea.
little Tomo app, and it looks like options.empty for now. Options. What is it? None. Okay.
And yeah, this is a good strategy that like sometimes very valuable, very like abstract, but like when you're figuring things out, sometimes it can be very good to be very concrete and say, like, okay, how the heck is this supposed to work in this one case?
Yes, we're sort of simulating how we would actually do this because we have not done this. We'll do pet, we'll do feed and dispose. So feed, and what do you, oh goodness. Sometimes in the pairing mode, this works a little, my Vim gets a little weird. Okay, so let's do a pet, feed, dispose. Okay, so ideally, we could just call, let me make a main method here just so we can muck around with these things. Main. So if I say Tamagotchi, I think it starts like that, Tamo.names, and print these out, it might just say Tamo. So we might want to do something that sort of first finds the subcommands and then gets the names out of there. We'll see. I think based on, I'm guessing the parent is Tamo and names is just going to be single, so that's all it's going to have. But we will see. Yeah, so it's just Tamo. So we can have a method called, gets, let me copy my other method. Get subcommand names, maybe. Names command, list of string. So then we could do, if it's subcommands, we could say child.names. Oh, it's a set of string, fine. Okay. And if it's an or else, I don't know if it really should be this. If it's a command, I think we do want to get subcommand names because we don't care about mapping at all. And we, I guess, don't care if it's a single. I don't really know. Set.empty. We'll see what it does in this case. When I run this, get subcommand names. Oh, or else. Yeah, sure. Case command. I shouldn't have just totally deleted that. Command dot or else. Okay, so this time, and actually let me make my console font way bigger. So I feel like that's way too small for everyone. 20. Doesn't really seem to change the size, but in fact, maybe if I run it again, it will change. Okay, so pet feed dispose. So we got them there. Now, whether, not entirely sure if that's valuable yet, because we kind of really just want the sub commands themselves and not just their names, such that if a sub command has more sub commands, we can keep following the path. So I think what we really do want is a sort of to re-implement the way this works. So commands. So I think if it is a single command, we can sort of just get ourselves.
Do we want all the sub commands, or should it just be like when you tab complete, like we just like you would tab complete like the next command, and then from there, if you try to do it again, you would show the next set of commands under that?
Oh, totally. But I think if you do tab it once, I'd imagine you would get, so let's say pet had another subcommand. You know, if you want to pet it
Oh,
on
right,
its
because you're not
on
in
its
that
body,
command yet. Yeah, yeah.
you're gonna get like a string first pet or p, and then you can autocomplete the
Yeah,
pet.
yeah.
But then when you do it again, you're gonna have pet, and then it's like, oh, do you autocomplete the pet, or do you probably jump forward because you've matched pet fully to all of its commands, pet head, pet butt, and so on and so forth. And then if you were here, you could do that. So yeah, I kind of want to follow this trail, I'd imagine. There's probably other clever things we could do by taking a look, but this would be, I think, a good starting point. So, but the way names was implemented was basically like, yeah, making a recursive function. If it is a single, it got single's name, but we want to keep the whole command so we can keep following its subcommands. And if it's or else, I think it was sort of get subcommand names for left, and then added that to get subcommand names for right. And obviously I need to rename this function in just a minute. And for map, we just throw that away. And for subcommands, we get, do we get the, I think that get subcommand names for the child, or do we get the, so this is interesting. It's really just for the first one that we wish to remove. We don't want to go through everything. We kind of just want to get it for the, I'm guessing a lot of these things will end with the subcommands. Let's see what this does instead of.
Yeah, I think we could also just get it working for some tree and optimize deeply message later.
Yeah. Gets, whoa, yeah, it's super weird. Oh man, what the? Okay, my Git is funky. All right, I will run this with its bad name. Type erasure. Oh, that's great. Yeah. Okay, ignore this. Okay, so now we got pet feed single. Great. I think the one problem with this is if pet also had, we basically want to get the tree of commands, like the full tree of commands. And maybe actually the way to do it is to actually not do this in 2 passes, but to actually take the string that we have so far and go through with it, such that if it matches,
we could use that information to
continue to go or to filter or something else. Yeah, so maybe that makes more sense. Then we get back a list of commands, which we then sort of stringify at the end. But then we also might want to like stringify the path. Though if we do want to just keep it very simple, we could, like, the first pass could be this, then we can try to connect it another way. There are many ways of going. Like sometimes it's good to do this. So let's say okay, we can get our subcommand names, which is really get subcommands, but my renaming is acting. I'll try it one more time. It's subcommands. Yeah, okay, just have to hit I first. Great. So we get this, we get a list of commands, then we just have to map really and call .name on them, or .names, I suppose, and then do whatever, toList, and then flat map them instead to combine them. I hope that works. I guess that there's a danger that, and I think this is good. We'll see. I'm going to run it. It should say pet feed dispose. Oh, and then, well, unless, yeah, I've got to call something. So let's do generate completions, and I will give it, oh, yeah. And then we can filter it based on sort of starts with inputs or contains or whatever. I guess starts with input. So let me do it with an empty string and our Tomo app, which should be all the options. Yeah, so there's a list of pet feed dispose. So if we just do F, it should just say feed. Yay, just feed.
Yeah.
Okay.
Nice.
Nice. So, so this is kind of the incremental, keeping things in that half broken state style that I'm using. But sometimes the problem with this is that you sort of implement something that works and it doesn't necessarily, you can't necessarily grow the shape of one solution into the next complicated version. But I mean, it sort of helps you in some ways, even if you have to sort of back up or delete. It can't always be sort of, you reach some local maxima and you cannot really extend linearly to the global maxima. You have to like sort of wander back. And I think, yeah, one of the problems with this is as it gets more complicated. But it would be a good idea. I'm going to switch back to the terminal real quick just to sort of see what does it look like with the real. So I'm using the real autocomplete. So first it shows way too much. So if I do it, let's do a complicated command, or what's one that's nested? Oh yeah, remote is nested. So if I do -R, it gives me everything, all these other commands only. So rem got remote. Now I hit tab again. Now I get all the other commands. So that's pretty simple. And if I get, okay, perfect. So yeah, it's only once I get to that second space. And I think the whole bit of actually completing this command and finishing it off is taken up by the framework. So we just need to, I think, just give it a list of sort of the finished commands it needs. I'm actually not even sure if we need to give it like the whole path. So that could be nice. I don't know, like, do we need to return a list of remote add? I don't think so, because it may know the context already and it's only adding the next segment to it. So that'll actually help us. For a second, I thought we needed to like track the whole path that we took to get here. But this probably makes it easier. And so, yeah, it's really just about this. And then we'll add origin. And then, so this is interesting, right? So this seems like totally custom. Because when you add a remote, it can have one of many what are these called? It's totally escaping me. But these browser prefixes, host something or other, pattern, domain, I forget. Protocol. You can have multiple protocols. There's protocol prefixes, and it looks like they've sort of retrofitted or added some intelligence to sort of like let you select these. And one could imagine if we knew that we had finished tracing out all the subcommands and we got to an args, like we knew we were now at a single. So like we followed this trail down of get remotes, add, then it actually knew didn't it also know a string? Oh, that's interesting, right? So it's also completing this from somehow. I don't know. I think these are already things I have here, so I don't know why I would add another one. But yeah, so this is the first argument we get to, and it's able to be clever. Basically, what this would look like is this, right? So we follow the commands. We're matching each parent's name, sort of peeling it off of our input list, and then we finally get to a single which has arguments, and so we could do single dot args, and then sort of do the same thing with this. But obviously args also can be combined because you can have multiple sets of arguments and stuff. So we can only probably be so clever. I think a good 1.0 would be to not worry about the arguments and to sort of take you as far down the subcommand path as possible and get more clever later. But what do you think?
I think that makes a lot of sense.
Okay, cool.
Yeah, I think another good principle is get something working.
Awesome. Okay, so I think what we need basically is, if I can imagine, each of these commands could basically be a list of strings. I don't know if we're going to return it as a list of string or get it as a list of strings. So we get easily split on spaces, because we're going to get some sort of spacified path of everything written so far. And then we can use that to sort of peel off one at a time until we get only a partial match for sort of the names of the direct subcommands. But like here's the place where if it does fully match the parent, yeah, it's kind of an edge. There's some strange things. Okay, let's see. So inputs or input. Let's say list of string, and we'll sort of peel off the head as we go. So oh yeah, the input. So I think if it's or else, we just keep the input going. If it's get subcommands, we keep the input going. Keep the input going. And here we want to check, I believe, if the maybe it's actually when we're at this command level, we want it to. It's a little tricky. Does this make sense? What I'm thinking about with input here? It's a little tricky to trace this as it goes. Maybe I should graph it out. So let's say we have. Let's go back to Git because this is actually. I don't know. We're using the one example. Let's do the pet thing. So we have this hierarchy, right? We've got Git pet feed. Yep. No, not Git. We've got pet feed head, not pet feed head. Yeah. Okay. We have pet feed treat and pet feed food, right? And then we can have pet dispose, right? So if our input is F, we want to, maybe I should make this another one, like furnish. We're going to furnish our pet's house. So if I do F, we sort of want to find every subcommand, every child subcommand, that starts with F. So we kind of want to get all the subcommands and match them. But perhaps when every time we come to a subcommands, we want to filter, because when we come to the second, if say the input was feed T or something like this, we're going to get feed, and feed won't really. We'd filter everything out if we just used feed exactly, but it will be a match for one of the parents, because feed has other children, and if it doesn't, then we're sort of done, and we shouldn't be trying to autocomplete any further. Like we only want to complete a command that has subcommands in it, so we need to match against the parent's name. So we need to sort of use, I think, the input's head against the parent, and if it matches, then we want to sort of use its children, and then yeah, not follow any other paths. Use its children. Oh yes. So okay, I think this is what I'm getting at. I know this is a little confusing. So if input dot head. Okay, I know it's partial. I'll do head option dot get or else. I guess empty string, or maybe I should make it a nonsense string so that it doesn't match anything. I'll just do this. So if input head option get or else empty string, or I'll match on it rather. No. So if this is equal to the parent's name and parent names, which is a little annoying. I don't know if it makes quite sense that a parent command would have many names. So maybe I could just say parent names, but who knows? Parent.names.contains. So if it's a perfect match for one of these parents, then we can keep going with the children. So we want to call get subcommands parent on the children, and the input now should be the input.tail. So we found feed, that was the parent's name, and so we want to pop that off essentially and keep going with T. Otherwise, if it does not match that, then we kind of just want to, if it doesn't fully match it, well, we still want, if it was just F here, we still want to sort of complete with feed, because we might want to autocomplete feed as the first segment and then continue later on. So we just want to really return this as though it were a single at this point. So return a list of just the parent, I believe. No, that's a little weird. And the other thing we need to do is sort of get the name of the application so we can itself and add it to the first argument so that we can parse this the first time, because we're not going to be writing Tamagotchi ever, but it's going to be in our first command list. And instead of making this really hacky and like parsing off the first command, we can just do it this way by like adding Tamo as though it were an input string always, so that we don't have to change this algorithm or make it wacky. And so we'll just sort of normalize the shape of the application. I hope that makes sense. I think there's still some issues with this, but I'm just going to run it because yeah, so basically, so get subcommands now needs a list of inputs. So this should actually now be a list of string. I guess I could do input.splits on space, and then .toList. And also I want to sort of add the name of the application itself, which I believe actually exists as, there's some prefix function, command.prefix. I think this is in the command interpreter. That's what they're using down here somewhere, prefix, which basically just gets the name of the first parent. Yeah, prepend the first argument in case the CLI app command is expected to consume it. Well, that already exists there as a private function. I'm just going to steal it for now. And that will basically get us the word Tamo in our case. So prefix commands, and we add this to our inputs. Inputs list. And it seems to be sad because this gets us back a list as well. So I should do ++, I guess. Okay. Fancy. All right, and let's see if this does anything. Okay, we still got back feed. Oh, and of course, that's cool actually that we didn't break it with everything there. And if I do nothing, hopefully it still says everything. But the idea is now we have to add subcommands to feed. So we needed to add treat and food. No, trait, what? Treat and food. Treats, food. Subcommands will now be treat or food. So if we first, type in F, we'll see feed. But if we get all of feed and it matches, then we should get the next set, which may be not working at all. This might be where we need to think about how this is actually executing, and is it going to keep going beyond the first match? So yeah, it seems like no. But it's a little confusing to me, because what would be happening here? We're going to be calling it on the tail. So yeah, I want to basically run this each time. So print line get subcommands, and I'm going to print out the inputs that we have, as well as our current command. I'm going to make this multi-line so we could really see what's going on. Probably should do another new line to separate these so it's not noise. Oh, that didn't even give me, oh yeah, new lines, duh, because I'm going to actually have new lines. Okay, let me try that one more time. Okay, so we can sort of see the structure of what's happening. Oh goodness, too many new lines. So this is too much. All right, so we have Tamo and feed as our inputs. So that's the whole application. And we came to subcommands first. And parent names did contain, hopefully, subcommands. And it seems like it because we recursed with just feed on the child, which makes sense. And then we're at these all of these or else's, and we have basically pet, feed, and then pet, sorry, feed, which itself is a subcommands. Ah, yes, which has treat and food and dispose. So now we have feed, which shouldn't match anything except for the subcommands, and it should keep going, I would think. Unless just no tail wouldn't blow up. I mean, it might blow up, but it's also okay because it shouldn't do anything. Let me do drop, drop one. I don't think that matters. Okay, so then we're going through pet, or else, so we're now calling it on pet, which should fail and return nothing, right? Because we get feed, we get pet. But no, it actually might return pet anyway at this point, because we're never checking to see if its name is contained here. So that's interesting. Yeah, we sort of like need some one other bit of state, I think. But then we come to feed. We do call on its children single on these two. And then we come to single, which it should return at that point, but I don't know why it doesn't. So I'm going to do one other thing, which is return this as like a result. And then maybe we could print out also what it gets as a result. Oh, and then we have to return the result. Okay, so, oh yeah, so it's going to show us everything, right? So oh, wait a sec. We get pet back. Wait a sec, maybe it's screwed something up. So we're calling feed. Get subcommand feed. Wait, why is it printing just this out? Oh, it's all in reverse order. Great, of course, because I'm sort of returning this at the end. Great, so we get a result of list of pets, treat, food, dispose. Pet, treat, food. Oh, wait, that actually makes sense. Why does it printing out list empty? I guess, oh, so yes, okay, that actually makes more sense. Oh, because then I'm filtering. I don't want to filter anymore because we're sort of doing the filtering inside of the application or inside of this other thing. We just want to filter. Okay, there we go. So it didn't totally break. We waded through food. So that was what I would have expected. We made it down to the inner food, but we also didn't sort of stop branching out on the other ones. And I think the reason is because we're getting the subcommands of the main one, which is Tamagotchi, and then we're only filtering ever if it's a subcommand. But if it fully satisfies one of these children, we don't want to try to do it on the other ones. Oh no, so yeah, we kind of need to filter here, basically. So it's going to basically be almost the same thing. If single dot names contains this, then we want to use it. Else we want to use nothing. I think that's the key. I know this is a very strange function. So I hope to see just treat and food now. I see nothing. Great. Let me print some stuff out. Okay, so single. So yeah, what is here when we come down to single? What is single dot names? And what is our inputs? So when we get to these things, we have pet, feed. So that should not match. Oh, and then we get, oh, yeah. It shouldn't be contains at this point. It should be starts with, sort of. So exists. Oh, that's great. S, so that starts with, I know this maybe seems psychotic, but anyway. So yeah, because now at this point we want to filter based on whether or not it starts with this. Hey, treat and food. Okay. So that's a weird looking recursive method. I hope that makes sense. We can walk through that again. I tried to think out loud, best I did. So that was like a simulated coding interview. Let me know. Like to no. Less stressful than one though. It really makes all the difference when you know what your ability to eat or not depends on. Okay, so does this make sense, Adam, in terms of what I'll just take a little break here. Are there any questions? Does the algorithm, what we're getting here as a result make sense before like whether or not the actual particular algorithm makes sense?
I think so. I think we have one comment about, I think just something we could have done within Z shell itself, that how that worked. So we can look at that. But yeah, so I mean, maybe let's just document for ourselves here. What's the contract of what the list of strings is supposed to be given this input?
So it's basically, so if we imagine as like a tree, and it's hard to write tree in ASCII, or a tree, or we can do a sideways tree in ASCII. It's hard to do a top-down tree in ASCII. But the idea is we have some sort of root command like Tamagotchi, which has a whole bunch of subcommands that sort of split out here. So there is Tamagotchi has I'll just do one. So the Tamagotchi has feed, dispose, and pet. And this one also has some subcommands, which is what is it? Treat and food. And so the idea is basically you start with some list of strings, which is the input. So if the user typed in Tomo F, we're splitting this into a list of, Tomo and F. Even though technically the app never gets Tomo because it's the executable name, so we have to synthetically add it back to the front as though it were typed in as the user typed in. So we can sort of have our algorithm work uniformly across without this weird edge case. And so what this should do is it should basically, if there are subcommands and the head of this input list matches a command or subcommands, then it should recurse down that subcommand with the children. So basically, if this was the input, we have a subcommand here, because the root was sort of a subcommand. It had a name, Tomo, it matched. So we peel this off the front and we recurse down its children with this next bit sort of filtering its children. And if this happens to match a subcommand fully, it'll then filter down its children and recurse down its path. But in this case, F doesn't match any of its three subcommands, feed, dispose, and pet fully, but it does partially match feed, so it should just return feed. So if we test this and we just do F, it should just say feed, I hope. Yeah, good, feed. And if we did just D, it'll say just dispose, right? And I think if it were...
And if feed didn't start with F, we would not show food, even though that's a valid thing because we would first need another F. Is that right?
So we would never show food unless we did feed.
Right, unless we match there, yeah.
Yeah, so and I just changed pet to fet so that we could see that if we could either fet or feed our pet. So yeah, it's going to just filter it based on that. And so, I think if if it is not a subcommand and you fully match it, you're just going to get back, I think, the same thing. That's not good. So there's something wrong there. Dispose seems to have matched. Oh, I know why. Because basically, if it fully matches it, we want to return its subcommands. If it partially matches it, we want to return the command. Otherwise, we return an empty list. And clearly, I can pull out some of these things. Parent.names. And put head option getter else. Reoccurrences. No, it's next, whatever, query, who knows. Okay, so yeah, now this should fix it. So the weird case is the subcommand is kind of like, it's sometimes you want to treat it like a single option, and sometimes you want to treat it as a potential thing to recur stem. So now by writing dispose, we just get dispose. But now if I do feed, we should get all of feed's children. And we do treat and food. And now if I just do feed T, we should just get treat. Cool. So I think that's kind of, yeah, it's sort of like this, you know, tree that your set of strings is a cursor down, a trail down, sort of like a try or something, but a weird try. Yeah. And so that's actually not so bad. I mean, and then eventually, once we finally do run out and like say it fully matches the single command, just like we do here, we sort of check to see if does it fully match the subcommand, then recurse. But here, if it fully matches, we don't do this yet, but if it fully matches a single command, then we can be clever and like go into its arguments and try to be smart about, you know, to do get clever about the option and args matching if query is a perfect fit. Okay, that's a vague sentence, but watch the symposium on this to remember. All right, that's cheating, but perfect. Cool. Well, yeah, I mean, not the most intoxicating thing, but like it's actually kind of simple. And this is, I think, you know, it's not maybe there's a better way of doing this. I don't know. But it wasn't the most trivial algorithm in the world. It wasn't the hardest algorithm in the world. It was like a slightly head-scratchy recursive function that will be, I think, fine. It is not tail recursive, but also your CLI apps should not have hundreds of thousands of nested subcommands. So I think we're safe here. That would be it's a code smell. And it seems to work with this. So I think the next step, and I'm not sure if we want to start poking around with this today, would be there's obviously some duplication and whatnot. But maybe the first thing to do would just be to sort of push up. Maybe let me not delete my examples actually. So I can push this up if I wanted to.
Yeah, I think another good guideline is like push when you have something. Like don't wait for it to be perfect because other people may have feedback on it that gets you going in a different direction.
Yeah, so to treat this like we're actually doing this thing. And oh, I have my various refactorings branch. So I did work off of a branch that I already had, which is, I think, mostly based on master. I don't want to merge that in anyway, but I'll make a new branch based off of various refactorings called begin, or what is it? Auto complete feature. Let's just call it that. And what did I do anything else strange? Oh yeah, so I mucked around with examples. I'm going to discard that, and then I will commit after, formatting. Let me make sure I formatted this thing. So begin work on generating autocomplete for bash zish. I did not. What did I commit? I did not. Oh, this is my. Looks like it was not formatted previously, so I'll add that. Sure, we'll get in there too, and I'll push that up to origin autocomplete feature, and then I will hit the fancy O key on my keyboard, which will take me to open a pull request, and I will, I guess, ask for John's review as well as yours, Adam, and say autocomplete feature. This yar begins to attempt to close. What were these? Zish cell script? No, 3. Oh yeah, this is a new project. And bash says issue numbers 2 and 3. To close issues. Let's go the nice direction. 2 and 3. We did this during a symposium. I will link the video. Can't think to type too much right now. And I'll make this a draft actually. How do I do this?
I think just the drop down under create pull request.
Thank you. Make a draft. Any feedback would be greatly appreciated. Happy Dagger.
What is that?
Yeah, it always confuses me because like I want to do happy face, but it's
wow, that's like very that's like
that's
give me your
auto-completing.
feedback now.
I'll do dango. I don't know what a dango is. That looks great. Looks like something a Tamagotchi would eat. Dango. Okay, or create as waste. All right, so draft pull request. I will throw that there. Lovely. It looks like it had some other, update versions and settings. So I should probably merge my other branch, but that's kind of the sort of an example workflow. Obviously, during ZIO Hackathon, there are going to be multiple projects in case ZIO CLI does not interest you. But I kind of like ZIO CLI. It's a neat little tool. It's very easy to sort of understand how all of it works pretty quickly, though it's not necessarily trivial. I don't think we really got into how it worked today. But if anyone is interested and would like to add to this, and we're going to be adding some more features and curating more features, both for this and other projects. I'm happy to work with you. We'll probably do another presentation like this, except one with more examples, and I'll be more prepared for that aspect of it. And everyone will be as well for their own projects that they're running. So hopefully it's a good time and everyone can open a bunch of pull requests and learn a bunch of things. And I hope I get to pair with some of you all out there next weekend. Goodness, so close.
Yeah, that'd be awesome.
Anything else? Do people know how to sign up if they're interested?
That's a great point. So why don't we, as soon as we get done with this, I will post a link to the hackathon where you can sign up and join us, get a free t-shirt. What's not to love?
Hey, look at this. Yeah, so Eventbrite. But yeah, basically just if you're on the ZIO Discord, you will see stuff. It starts on Friday, October 27th at 7 p.m. UK time, which will be, I guess, 1 p.m. here and noon in Crested Butte, Colorado, where we will all be.
High noon.
I don't know why we'll be there, but it sounds great. I'm not going to question it. Very excited. Excited to finally meet you, Adam.
I know.
In the flesh. But yeah, thanks everyone. I hope that was semi-interesting. I know it's a bit of a strange one, but we'll see. Hopefully you'll get in the weirdness with us next week. Ta-ta for now.
Bye.
Bye, everybody.